I'd like to show you the forming analysis for the RV50 part at this time. I'm going to show you first of all number 11 analysis, and I did I think 1 through 5 or 6, and then I started with 11 to keep them straight between the two. This particular one has no draw beads, and just showing it to you so you can see the wrinkling that's going on, kind of to use as a benchmark. And this is at 100% punch stroke. This area through here, it's got that angle on the die, so we're actually smashing, if you will, the wrinkles at the end, at the last stroke. So if we move to 90%, there you can see the wrinkles very vividly, of course. And I also did an analysis on part earlier yesterday with excuse me, draw beads that are very similar to the ones that are seen in the photographs that you sent, and we get substantial wrinkling there too, because we need draw beads around the corners. We need the draw beads going around the corners, and we'll show you that at the end of the video. Show you what the draw beads look like. And let's also look at number 12. This is the main one, the 24 thousandths thick material, the cold rolled IF electric valve. And let's look at the safety zone. And we need to click on that arrow before we can use the arrow keys on the keyboard to cycle through it. So you can see a little bit of, I don't know if I'd call it wrinkling, that's starting here. Go the other direction. Because the material is really just being pulled taut right there. But again, with the draw beads, as you'll see them here at the end of the video, and again they wrap around the corner and go around the side partially. You can see just a little bit through here. I'm not sure, frankly, if there's something graphical going on there, or if you will see some very slight wrinkling through there. But of course, nothing at all like in the photographs. And then let's switch to safety margin. And the safety margin, excuse me, when you hit 0, 1 is virtually virgin material, and 0 is when the material starts to fail. So there you can see that we're at 0.202. And you can see the area that is thinning the most. Let's look at the forming limit diagrams. That's at 100%, and we go down to 90, and of course the forming limit diagram gets better and better. And look at the thickness percentage and change to calculated. And we're at about 17% right in this area. And about 12 in the back here, I guess. Now there's some areas that aren't perfectly tangent on this part, particularly in that area that I just highlighted. Let's close this particular project, and the last one I'm going to show you is number 16, excuse me, and that is the 18 thousandths thick material. And that certainly gets much closer to a safety margin of 0. Let's look at incremental and safety zone, and you can see that we're just marginal in this area right here. And if you look at the model, there's some definite issues with tangency right there. It is definitely not tangent through here. It's relatively sharp. That if you soften that just a bit, it may help a whole bunch. I know you've got louvers going through there, but I hope you've got a little bit of room to soften that just a little bit, because I think it'll make things much, much nicer. So again, this is 18 thousandths thick material. Even here at 70% punch stroke, you can see that that's pretty pronounced already. And reverse directions. Very similar to the 24 thousandths thick material, other than you've got more thinning going on. And let's switch to safety margin. And in fact, we are at 0.025, so it's thinning a fair amount in that area. And you can see the marginal points on the forming limit diagram. And the thickness percentage, let's zoom in a little bit. And let's change that display scale to calculated, and we can see that we're at about 23.5% thinning in this area. And again, so this is the 18 thousandths thick material, and I did the aluminum 3003-0 that was in our database, but it failed very, very quickly into the stroke. So unless you can get me the N value, R value, and ultimate tensile strength, or K value, of the 1100-0 that you're using, I'm not able to run that. But if it's working in the existing die, I see no reason why it wouldn't work here. We do obviously have a bit more tension on the sidewalls, though, with the draw beads going all the way around, as you'll see momentarily. And so let's look at the draw bead area. Let's go to Process Setup and draw bead 1 and draw bead 2 and draw bead 3. And then let's look at those on the model. And let's look at the sketch for the approximate locations, and I'll give you a bit more detail on that as well. And the blank size, again, is 20.625, as you can see down here, by 19 inches. Thank you very much.